morning. Welcome back to the course on engineering metrology, and I am taking statistics in metrology in this course. In this lecture, I am going to discuss some fundamental concepts of statistics. Owing to the feedback that we are getting on this course, I have designed this lecture to shed some light on the fundamental concepts of statistics, specifically in metrology. So, I will talk about descriptive analytics here. As I said before, descriptive analytics tells or it directs towards defining or explaining the data or presenting the data in a proper way. The data is present, the data that we call the observations that we have done through instruments, those are there. We have to describe that in some way. We have to find the average, the mean. This mean fall in which class? It is the central tendency. Central tendency, then we have standard deviation, that is dispersion. What is the spread of the data? That is dispersion. Then we have position of data. I also discuss about the median. The median is actually position of data. Where does our data lie? Where is the observation that we are having? Where does it lie in the complete data set? Then we will talk something about the data visualization, how to graphically represent the data. I will start from descriptive analytics, or to be more focused, descriptive statistics here only. These are the 4 components that I just discussed in the contents of descriptive statistics. Number 1 is central tendency. Central tendency, or what we call the value of data. Not only value, I will call it the predominant value of the data. Predominant value of the data, the complete data, that value we are trying to find, that should be close to the true value. What I am telling, it should be, whether it is or it is not, that is a different question that we have to deal while we deal with the errors, but it has to be, it should be actually close to the true value. The measure of central tendency is a single value that describes the way in which a group of data cluster around a central value. To put in other words, it is a way to describe the center of the data set. Next is dispersion. Dispersion is nothing but spread of the data. The spread of the data. Then position of data. Position of data, when I am talking about the position is always with respect to some other points. We have the whole data set. Where does our data lie in that? With respect to the available or the observed values, where does it lie? So, it is in relation to, I would say, in comparison to other data. Okay, data, or I call it data points. Next is data visualization. Data visualization is nothing but the graphical representation of the data, whether it is graphical or whether it is in tabular form. When we present the data or when we write the report, the conclusions or the results that we write is a different thing. That is actually prescriptive statistics. In descriptive statistics, we just need to present the data in the proper way. For that, what kind of plot shall we use? So, that is important, that is graphical representation of the data. So, let me start from the central tendency. There are 4 measures of central tendency, which are mean, median, mode and mid-range. So, most of you must be knowing what is mean. We frequently call this value as the average, mean, or the typical value that the data should attain. So, this value is nothing but it is the arithmetic mean, I would better put. Arithmetic mean, which is generally denoted by x bar if the data values are xij. These are my data points. So, this is my average, or better we call it mean. So, this value, this is actually the value that we receive when we ask for the average grade or the average high or low temperature for a specific environment. For when we say average temperature in a day, or average temperature of the city in a month, something like that. So, it can be denoted x bar is equal to summation xij by n. Okay. Similar to mean, we have median. Median is the central value. Mean is in continuous data, we have a set of values. We just take the average, we sum up all those and we divide it by the total number of values that we have, that is mean. Median is the central value. It can lie in the left or right of the mean, that we will discuss when we discuss the normal distribution, and we will focus on the skewness in normal distribution. We can see how mean, median, mode are differently located. So, median is the central value, it is the central value. To write it more clearly, I would put it, it is the middle value. Middle value of the data when the data is arranged in ascending order or in some order. It is arranged in ascending order. It may be arranged in descending order as well, because the medium or the middle value shouldn't change, but ascending order is the first criteria that we follow. When the data set or the number of values are odd, then the middle value is the median, but when the data set contains even number of data points, the value between the two numbers is actually the median value. So, median value in general is denoted by subscript d is equal to, this is equal to n plus 1 by 2th value. Please note that this is not the n plus 1 by 2 value, it is the n plus 1 by 2th value. If I have 9 data points, it is 9 plus 1, 10 by 2, that is the 5th value. 5th value can be anything. In case of like we say temperature, it can be some temperature value. Okay. So, it is n plus 1 by 2th position or value. So, where 1 is the position of the smallest value and n is the number of the pieces of data, we can say it in this way as well. I will just do the calculations. This is actually just an introduction, and the purpose of this lecture is not to just tell about the mean, median, because you people might be knowing this thing. I will practice this, I will make you to learn how to calculate this using Excel sheets, how to actually calculate how to actually make the use of computers to calculate these things, and then we will also take it forward to the quality control, where we will plot X bar chart and R chart and other charts like this. So, next value is, or next central tendency is mode here. Mode is denoted by m subscript o. It is the value that occurs with maximum frequency or the greatest frequency. The value that occurs with maximum frequency. It may exist as a unique value, or it may exist as a number of values. For instance, there are 10 data points and the value range varies from 5 to 8, and it is the number 6 that is repeating 3 times, and none of the other numbers is repeating this many number of times. 6 can be the mode. If 6 is also repeating 3 times and 7 is also repeating 3 times, we can have 2 modes, but we cannot say 6 plus 7 by 2, 6.5 is mode. Okay. So, mode is the value that occurs with maximum frequency. Next is mid-range. Midrange is the midway between the highest and lowest value. Midway between the highest and lowest values. So, if let me say if I like I am talking about 10 values, it varies from 7 to 8, the highest value is 8, the lowest value is 5. The mid range would be 8 plus 5 by 2. It is actually h plus L by 2, where h is the highest value and L is the lowest value. Okay. Now, the 4 measures of central tendency represent the 4 different methods of describing the middle value. These might be same in some case of data. If data is behaving very symmetrically, these 4 values may be same, but in general the values are different. Okay. Now, where do we use mean, median, mode, that I will come when I will discuss about the normal distribution also. Okay. So, also I discussed when I discussed about the scales, the nominal, ordinal, interval and range scales. Where can we use mean, median and mode? Like in nominal scale we cannot use 3, and in case of the ratio scale we can have all the 3 values. Okay. Next is dispersion. Dispersion means the spread of data, and the spread of data can be found from 3 different ways. Number 1 is range, number 2 is variance, number 3 is standard deviation. Now, these terms range, variance, standard deviation, they assign a numerical value to the amount of spread of data set. So, it is the spread of data and we assign a numerical value here. Okay. So, number 1 is range. What is range? Range is actually, as I said, the highest value is there, lowest value is there. Midway range was the average or the middle value of these. Range is nothing but the difference between 2. R is equal to h minus L, where h is same, the highest value, L is the lowest value, and the range is the simplest measure of dispersion. Okay. So, we will draw the range or R charts. And what does this signify? Within a subgroup, when we have different samples and for each sample we have different observations. For instance, you need to find the diameter of the shafts and you select the shaft 10 shafts after each hour in a production facility. After each hour and in a day, in an 8-hour working day, you select it 8 times. The sample size can be, you can select, let me say you select 10 shafts, okay, the sample size is 10, and in an 8-hour day you select it 8 times. Okay. So, in that case, within one group that consists of one group is that is within one selection, within one lot, that is of 10 shafts of which you are interested in finding the diameter. What is the range of difference? What is actually range actually? What is the range which is the difference between the highest diameter and the lowest diameter? And in the second group, what is the difference? So, we generally draw, we will draw it actually in X bar and R charts, these are R charts only. We will draw and we will see where is the range varying. For instance, let me say in the start of the day the range might vary like this, and during the day the range might be quite close. So, this means that while you make the setup, the very first value shaft that is manufactured or when we change the shift, okay, in the start of the day, there might be some difference in the diameter that is occurring. Okay. So, these inferences can be drawn from this. So, this is the application that we will do in quality control. So, just this is the lecture to prepare us for the Next discussions that we are going to do on the quality control, on the normal distribution, etc. Next is variance. Variance is denoted by sigma square. It is calculated such as summation I is equal to 1 to n xi minus x bar whole square by n minus 1, where x bar is actually mean. Okay. So, another way to calculate x bar is mean, I can put the value here of x bar and open the bracket here, then it becomes summation I is equal to 1 to n for x square minus summation x I is equal to 1 to n whole square by n over n minus 1. Okay. This is taken separately here. So, when x is an individual value, the mean and the n of in the sample size, the simple formula is used here. Okay. When x is an individual value. Next comes the standard deviation. It is denoted by sigma, and it is actually the sigma is equal to under root of variance. So, if I take under root of these values, that is under root of summation I is equal to 1 to n x minus x bar whole square by n minus 1, you can derive the other relation from this as well. This is standard deviation. So, standard deviation is one of the most used measure of dispersion. The reason for this is that there is square of the values, the square of the differences. Okay. Even when the differences lie above or below, that is in towards the positive or the negative sides of the central tendency, it actually neutralizes that effect. That is not taken into account in this, but range is simple linear or the arithmetic difference. Okay. And standard deviation plays a vital role in normal distribution, and in many distributions. For the normal distribution, there are two statistics, mean and standard deviation only. So, next I will discuss about the position. Position of the data is determined by the quartiles and percentiles. Actually, percentiles are derived from the quartiles only. If I divide my data in the number of values that we have into, let me say, 4 parts, okay, and I say 25% of data is here, 25% here, 25% here, 25% here, that is if n is equal to 20, these values are 5, 5, 5 and 5. Okay. Or either you can say this is first value, this is 5th, this is 10th, this is 15th and this is 20th for n is equal to 20. Okay. This is known as quartile. Similar to quartile, we can have percentiles. If I divide it into 100 divisions, okay, and I put 1 here and 100 here, I can put 10 here, 90 here, and in between I have 50. These values can be called the percentiles. There is another term known as quantile. I just picked the quartile and percentile because these are the most used, otherwise quantiles can be any number. We can divide the whole data into any number. For instance, this is 20, I can divide it into 5 parts. So, this becomes 1, or I can call it first, actually the first number. This is 100th number, this is 90th number. Okay. So, it is first and 20th. Here what I will have 1 to 4, 4th, then 8th, then 12th, 16th and 20th. So, this is quantile. Percentile is 100, quartile is 4, any quantile, this is 20th quartile. Okay, quantile, 20th quantile. I can divide it into any point. This tells us the position of the data. So, this would be used when we will plot the box and whisker plots, or when we also need to know the skewness. Okay, skewness, the coefficient of skewness or the extent of skewness can be calculated using the percentiles, using quartiles and using median, and this can be utilized in that. Now, I will try to solve an example here for all these values. So, a set of 10 measurements were taken from a sample. The values in millimeters are as follows. Okay. These are the values. When we need to calculate the mean was x bar, which is equal to summation x by upon n. These are 10 values. So, I will divide it by 10, and the 10 values, all these values 15.06 plus 15.03. This is very simple thing, you people know. I will just put it here, all the 10 values and divided by 10, and I will calculate its mean, that is equal to, actually all the values are greater than 16. You know, the interesting thing here is that the values are 15.06, 15.03. If I take the mean of the values after the decimal places and then take 15 into account, that can also solve. So, I can also do it like in a way, I can subtract 15 from each. I can just take the mean of 6 plus 3 plus 8 plus 5 plus 3 plus 5 plus 6 plus 3 plus 8 plus 3. I can take mean of these as well, only these values. That can also do. Okay. But okay, I have just put it, the value, the mean here would be 638, 15. It is, the sum is actually 50 by 5, 50. So, it is 15.05 millimeters. Okay. This is mean. Next is median. For the median, as I said, we need to first arrange the data in an order. The order that we have selected, or that is generally selected, is ascending order. So, I will arrange the data in the ascending order. The smallest value here is 15.03, first value. Second value is again 15.03. Third value is 15.03. I missed this one. This is fourth value, 15.03. Then fifth value here can be 5, 15.05. Then sixth value is another 5, is 15.05. Then seventh value is 6, 15.06. Eighth value is another 6, 15.06, and ninth value is 8, and 10th value is also 8, 15.08 and 15.08. When I arrange these into ascending order, these are actually arranged in ascending order. Okay. So, now we need to calculate the depth of the median. Since the number is even, when the number is even, I would like to better explain it here only. For the median, when the number is odd, here it is when n is odd, but when n is even, median is n by 2th value only, n is even, okay, when n is even. So, the number of values are 10 here. So, the depth of median I will calculate here, depth of median is equal to 10 by 2th, 10 by 2 is equal to fifth value. Okay. So, when I say 1, 2, 3, 4, 5 and 6. Okay. So, this is equal to depth of median is equal to fifth value and median is 15.05. So, in case of continuous data and in case of discrete data, there is a little difference. In case of continuous data, in this case, because the number of values are even here, we can take the average of fifth and sixth value, because the average means something, it can identify something, it is the length actually in millimeters. Okay. So, we can say the median is equal to 15.05 plus 15.05, that is fifth value plus sixth value by 2 is equal to 15.05. Okay. So, if the data is completely discrete, we can say the two median values exist. Okay. We cannot just add the fifth and sixth value. So, next we will calculate the mode for this. For mode, let me see how many times are these values repeated. 15.03 for mode. I need to see the frequency of 15.03, 15.05, 15.06 and 15.08. 15.03 is repeating 1, 2, 3 and 4 times. I will put frequency here. It is repeating 4 times. 15.05 is repeating 1, 2 times only. 2 times. 15.06 is repeating 1 and 2 times. 15 is also 2 times. So, this is 2, 2, 2 and 2. So, there exists a mode. Mode is 15.03. So, mode is the maximum frequency that we have. So, therefore, mode is equal to 15.03. So, mode means the center point in the frequency. If I say this value is from 15.01 to 15.08, okay, these values are varying like this, and this value 15.03 is repeating 3 number of times. If I call the frequency here 1, 2, 3, 4, actually 15.04 is repeating 4 number of times, and 15.05 is repeating 2 number of times, 15.06 again 2, this is again 2. So, this kind of frequency distribution is here. Okay, 15.05 and this is 15.06. So, we have mode here. Next, also we can calculate the measures of dispersion here. Okay, again we have taken the same values and we need to find the range, mid range of the data that was taken in the experiment. The range, the maximum value here is, for the range is highest value minus lowest value. Highest value here is 15.08 and the lowest value is 15.03. So, this is the difference between two, that is equal to 0.05. So, this is my range, and mid range is mid range is 15.08, that is the highest value, plus 15.03 by 2. This is equal to 11, 15.055 mm. This is mid range. So, as I said, the purpose of this lecture is not to just recall the statistical concepts, the fundamental statistical concepts that you have that you might have learned in your matriculation or in your senior secondary. schools, but to use the Excel tool. We can also use R tool. If you like, we can also provide you some notes on that, to use the coding language R to calculate these simple observation or simple results. But for now, I will just use the Excel sheet. I have put the data in the Excel sheet here. Oh, this is length in millimeters, the data that was given. First of all, I will put numbers here 1, 2. You know, if I select 1 and 2 together, first of all, if I select a single cell, I select single, it is selected using this green box is occurring here. If I come at this, if I come at the center of the cell, this kind of plus is there, which is actually a select tool. If I drag it here, keep on dragging, it will just select the column, it may select the row, it may select this column, it may select the whole matrix here, whatever you like. Okay. So, this is select tool, and this is arrow type tool. This tool is the move tool. I can move it, this value in any cell I like. Okay, I will move it back. Another tool is there, which is actually the formula drag tool. The simple plus is there. If I select this single cell here, which is cell A2, this is cell A2. If you see, this is column A, row 2, column A, row 2. If I select this cell A2 and drag it here, the number 1 will appear. Drag means the whole, that formula is actually dragging down here. But if I select these two cells, it will drag down and put the serial numbers from 1 to 10. Okay. So, I have just put a serial number here, because I will need to, I will also do the same calculations that we did, the simple calculations with pen. I will also try those calculations in this Excel sheet. Okay. How to find the median, how to find the mean in Excel. However, there are direct formulas to find variance, standard deviation. Excel is a very versatile tool. We can do all the regression and many things, like if we have to really exploit or explore actually the Excel tool, it has many things in it. Okay, it has macro, it has certain annotations and many things in design and all those things. But the simple calculation if you would like to do, if I need to find the average of this data, I will just put, I will just select this cell, put this is equal to AVE. You know, selection is there, options are coming here. This is average of these cells. I have selected these cells. So, this arrow, these dots are moving, that means this is being selected, not selected, being selected. So, if I put enter here, it will give me average here. I will put average here, or I will better put mean here. I have put mean here, the mean value is 15.05, I will color it red. Okay. So, mean value is there. I can also find median here. Median, this is equal to median of these values. Median is again 15.05. So, let me try to find the mode. For mode, I need to put here mode. Okay, mode is also coming. Let me try. Mode is 15.03. So, if I see these values, these are the exact values that I calculated using my pen only. Okay. Mean, median and mode. I will put different colors here. Another way is, if we need to arrange this in ascending order, okay, what I can do, I can select these values and then sort here, sort and filter, sort from smallest to largest, or I can sort it from here, sort from smallest to largest with just sort the column A, which is always already sorted from smallest to largest. If I do from largest to smallest, so largest to smallest, you know, the values are changed here. It has sorted from the 10 to 1. the value corresponding to 10 is 15.03 only. We can pick any value corresponding to 5 is again 15.03, okay. Value corresponding to 3 is 15.08. If I undo this, control plus Z is undo, you can see value corresponding to 3 is 15.08. So, I like to sort the column B, these values, I like to sort these values in ascending order. So, I will do custom sort here, I will select sort by, not column A, I will select sort by length in millimeters, which is column B, values smallest to largest, okay. Now, these values are arranged in ascending order. If we need to calculate the medium in a way that we said, if we need to find now with the 10 values, we can find the middle value, this is sorted in an ascending order, okay. But I am more interested in finding the standard deviation here. So, I am going to pick this second formula, that is x square, summation of x square minus summation of x whole square by n. Actually, this is summation of the values, the squares of the values. This is sum of the values and the square of that, okay, by n and by this is completed by over by n minus 1. So, I will pick this formula to do my calculations here. So, this is xi, the column B contains xi here from B2 to B11. I will better put sum in between here, I am just moving it down, I will put sum, okay, the summation, sum, this is equal to sum of, if I put is equal to sum, this is equal to sum, if I put sum here, this is equal to sum of these values, enter, sum of these values is 150.5, okay. So, now I will square these values, this is equal to 15.06, so value B2 hat 2. This symbol hat here means the power of the number. B2 hat means B2 power 2, B2 power 2 would be square B2, B2 power 3 would be the cube of B2, B2 to the degree of 4 maybe B2 power 4, I can put the values here, but I am more interested in the square here. So, B2 square, this will square this value, this is actually 15.06 square is equal to 226.8036. So, I will drag this formula here, let me see is this formula correct, okay, yes, this is B3 square, okay. I will drag this formula to all these 10 values. Now, I have xi square, this is x, okay, I will put another row here, I can just select and insert, it will insert a row above, this is xi, this is xi squared, okay. I will wrap the text, will bring it in like this, okay, xi squared. So, this is xi squared, summation of xi square, sum of this. If you like I drag the formula in the column, I can also drag the formula in the row. This is sum from the values B3 to B12, these values which are in a blue box, in a big blue box. If I drag this formula here, it will also bring the formula to the C column. Now, if I see this is sum of C3 to C12, this big blue box, sum of C3 to C12. So, I have got this summation of xi squared and this is summation of xi. So, the formula was summation of xi squared, that is 2265, this is equal to, okay, I need to square this as well, summation of xi whole square. So, let me put it here, okay, I will drag it further down, I will drag it down and I will put here sum squared, okay. Now, this value is equal to square of this value. So, the formula is, to recall, summation of x square minus summation of x whole square. This is summation of x squared actually, summation of x squared minus summation of x whole square by n, and this whole, the difference of these divided by n minus 1. So, using this formula, summation of x squared is 2265 and summation of x square by n, this is equal to, I will put here, this is equal to summation of x square divided by n is 10, this is this value, this is actually summation of x square minus divided by summation of x square by n. Now, difference of these values, summation of x squared minus this. So, I will put this value here, this is equal to summation of x squared minus summation of x square. Okay. This value, whatever this value is, now variance is equal to, I will put variance here, variance is equal to this value divided by n minus 1, 10 minus 1. This is my variance 0.004. So, what if I will put a variance here, what if I just calculate the variance using some formula in Excel. So, variance, I will just pick the variance of these values just to check, just to cross check this thing, variance of these values. Yes, the variance is same. Okay. So, we calculated the variance using the given relation or the formula. Also, we see that the variance is same. Okay. Like you can just find the variance, you can just put the command is equal to variance, it will just put the formula and calculate the variance. So, these are only 10 readings. We can have thousands of readings. If I have thousands of readings, we need to divide it into subgroups. We had to do multiple calculations. For that, pen wouldn't work. We have to use this Excel. Okay. So, variance also we can calculate standard deviation. Standard deviation. Standard deviation is square root of variance. This, okay, I will first calculate my standard deviation. This is equal to square root, SQRT, square root of this value, enter, this is 0.02. What if I calculate standard deviation, or if I try to find standard deviation using the Excel formula, standard deviation of the values from B3 to B12, okay, enter, this value is same. So, I pick the formula of standard deviation here and found the standard deviation value as 0.02. I calculate the standard deviation, it is 0.02. I put the formula for the variance, it is 0.0004. I calculated using the relationship, it is same. Okay. So, this is actually the use of Excel. We will keep using the Excel tool for further calculation. We will also see when I will discuss in the next part of this lecture the various plots. I can see how can we plot variance graphics using Excel sheet. We have insert here and we have many charts here. Okay. If I open the chart, this is actually kind of bar charts. We have stacked bar, the standing bars, we have scatter diagram here and line diagram, pie chart. Okay. So, I will discuss about data visualization in the next part of this lecture, then I will use Excel to plot something. Thank you.